Welcome to this session entitled ArcGIS Automating Topographic Data and Map Production. My name is Amber Bethel and my co-presenters for this session are Johnny Beavers and GC Rice. All three of us are product engineers on the Topographic Mapping team at Esri. Our team develops the ArcGIS Production Mapping and ArcGIS Defense Mapping extensions, as well as helping topographic agencies to implement Esri software to meet their data and map production needs. Topographic data and maps provide a foundation that can be used for visualization, analysis, and planning to help solve real-world problems like recovering from a natural disaster. In order to meet those needs, it is critical that the foundational data used be authoritative, accurate, and up-to-date. This session will focus on how topographic agencies can use automation to help create and maintain high-quality data and maps. Throughout the session, we will be discussing a number of ArcGIS Pro extensions: Workflow Manager, which can be used to standardize your business processes; Data Reviewer, which can be used to validate that your data meets quality standards; and the Production Mapping and Defense Mapping extensions, which are used to streamline data and map production. In addition to the tools installed with ArcGIS Pro, files such as data models and cartographic rules are part of a separate product data installer. Defense mapping contains pre-built configurations to support defense specifications like TDS and MGCP. Production mapping provides CTM and template files that are more appropriate for civilian agencies who have custom specifications. Regardless of whether you are producing content for civilian or defense purposes, central to your production is the best scale data. We use this term to represent the data collected at the most detailed scale within your organization, whether that scale is 1K, 10K, 25, or 50. The best scale varies depending on the needs of an organization and the area being collected. But regardless of the scale, agencies invest a lot of time and money to create and maintain this data. In this session, we will show you how to streamline collection of the best scale data, how to create data and map products using generalization and cartography, how to collaborate and engage with internal stakeholders and external customers. And finally, throughout this session, we will be discussing how workflows and automation can be used to ensure consistency and speed up manual tasks. So let's get started with our first topic. How do you create best scale data? While emerging technologies like artificial intelligence and machine learning can be used to assist with some data capture efforts, it is still a largely manual process. Workflows can be used to streamline the process, and pre-configured data models, feature templates, and validation rules can be used to provide consistency. At this point, I'm going to hand the presentation over to GC, who will tell us more about data capture and workflows.
All right, thank you, Amber. So the first step in the process is data capture into that best scale database that Amber was discussing. We do that within workflows, and actually workflows underpin all steps of the process. So production mapping has workflows for data capture, generalization, and cartography, and more. So we'll start by discussing the workflow framework, and then we'll dive into some demos that actually show these workflows specifically for data capture. So a high-level workflow for data capture, which includes editing and quality control, could look something like this, but with Workflow Manager, it's not just a flow chart, it's actually integrated into the software. So for example, with Workflow Manager, the system can ask me questions. So is my imagery ready? And then it can branch based on my decision. It can also run automated processes. So we could have the Clip GP tool, for example, run automatically with the correct parameters already populated. Or we could create a version in the geodatabase automatically as well. Workflow Manager can also launch applications. So oftentimes that's steps within ArcGIS Pro, for example, for editing and quality control. The nice thing is that it can launch the exact Pro map or layout that I've already configured, zoom to the area of interest with the right data already in the map. Along the way, Workflow Manager is documenting information. So it's recording each step that was run by which user, what time, and the result. You can also record information manually as well. So for example, I can add notes to the job that everybody in the shop could see. Now, along those same lines, there's also an email capability. So emails can be configured to be sent on any system event at any time in the workflow. So it's just all about improving that transparency and fostering better communication within the production shop and across all types of staff. Now, ArcGIS production and defense mapping include predefined workflow manager workflows for topographic production. Now, these workflows are designed first and foremost to increase productivity. We do that through automation, so many steps and some entire workflows are completely automated, no user interaction required. Jobs are also created automatically when they're ready also. So as soon as that data editing job finishes, the quality control job is automatically kicked off and assigned to the quality control user group. Now, along the way, we want to also build in quality. So we do that by managing and enforcing the quality control, meaning data can't be published until it passes that quality control step in the workflow. We're also automatically setting lots of key files and paths. So you can see the window on the screen with the production and cartography properties. All those paths and parameters are automatically set based on our configuration decisions we make during deployment. So the idea is users don't have to enter any of this, it's automatically set for them. So it's both minimizing the user error and then also enabling that automation I mentioned before. We can also configure the system to ensure edits are in the right area, so optionally restricting users from editing outside their geographic area of interest. And then we're also managing the data updates, so checking out data, checking in data, reconcile and post. All of this is fully automated in workflows. Now, these workflows come in the box with the production mapping product files. So we've got workflows for data editing that I'll cover, cartographic production that Johnny will discuss, data ingest, field editing, data generalization, which Amber will cover, and data labeling. The system also includes sample workflow manager user groups, so you can see those on the right. These are roles that already have the privileges defined, so it's just a good starting point for you to group your users in the system. We also include geoprocessing tools to help you deploy and configure the system. So importing the workflows and then configuring them to work with your production files, your maps, your geodatabases, your network file share. We also include a deployment guide that covers the entire deployment process. So let's jump into our first demo. First, I'll show management level users interacting with the workflow system, and then we'll see how technicians actually complete the data capture within that same system. All right, so I've got my topographic mapping portal. I'm logged in, and I'm interested in tracking production in the system. We have an application for that called Production Manager, so I'll open that now. The Production Manager app comes with ArcGIS Production Mapping Server, and it uses Workflow Manager Server behind the scenes to connect to the workflow system. It's a portal configurable app, so that means I can configure it without any code. So for example, I can set up different queries in the system to investigate different types of production. The CTM is civilian production, so I can look at the civilian extraction jobs, or what we call data capture jobs, versus civilian map production jobs. Or I could investigate the defense schema as well. So in this case, I have MGCP and TDS production happening in the system. If I want to look at that MGCP production, specifically data capture jobs, I can click that query now, and we'll zoom to an area where we've got some MGCP production happening. So you see I get a sortable table view of all the jobs that match that query. Now I can view the jobs in the table, or I can just click them on the map, and you see I get a pop-up that shows me percent complete, date, and status information. As a manager, though, I'm probably tracking dozens or hundreds of jobs in the system, so I need a more thematic way to view what's happening. So I can get that using the job status pie charts. For example, the scheduled status chart can show me jobs that are on time versus behind schedule, and then finally jobs that are already past due. And you can see I can isolate those on the map using the pie chart. So this allows me to drill a little deeper on these jobs that are falling behind or already past due. So in this case, if I want to figure out what's going on with these jobs that are behind schedule, I can isolate these and get more information on the job details tab. And here I can see all the properties for this job. And it's a live look at the same job that the technicians are working on in Pro. So for example, percent complete, I can see this job is 50% done. That's calculated automatically as the technicians work through the workflow in Pro. Now I can scroll down a bit and see that this data captured job's in the quality control phase. You can see the subtasks involved in this data capture job too. So you can see that there's a create replica task that's already done. The data maintenance is done, meaning data capture. So quality control is where we are now. The last step would then be to publish those updates. All of these subtasks are tracked here with their data information. You can also get even more properties. If you scroll down, all the key paths and parameters that are used by the workflows are here, and these are the same that the technicians see in Pro. And beyond viewing all of these job properties, I can also view or add notes that the technicians would see. I can also add attachments for them. In this case, I can view attachments as well. These are logs that have been automatically attached to the job for key geoprocessing steps. The key here is that it's one system. So everything I'm doing and seeing here in the web app can be seen by the technicians in Pro. We've been looking at existing jobs, but I can also create new jobs through the app as well. So for example, if I wanted to create an MGCP disconnected production job, so this would be data capture with a checkout replica, I can do that here. So I can drag a box and get one or multiple cells. I can see the multiple cells there, or in this case, I'll just grab one cell. When I click that Create Job button, it's going to kick off a new production job in the system. And so I can see that job's created here. So now we've seen how a manager can task and manage production through the web app. We're going to switch gears a bit and see how technicians would be working with the exact same system in ArcGIS Pro. So I'll bring up Pro, and you can see I'm logged into that same topographic mapping portal. We're looking at the workflow view here. So Workflow Manager is built right into the Pro framework. I've got queries on the left here, which control what I see in the job list, and map view on the right. So looking at all open jobs in the system, you can see that job I just created in the web app, which was 12818. I can click it and it'll zoom me there in the map view. I've also got other queries though that can help me slice and dice the job. So I can query by open data maintenance work, for example. So here I see the data maintenance and quality control jobs, or I can view cartography work, so jobs for creating map products and doing the revision. I can also look at jobs we created in the web app. So for example, 1632, that's a job that was in quality control and 50% done. Now some subtasks have already finished for job 1632, and we can see those under closed jobs. So you can see the data replica job and the data maintenance jobs are closed. They're already finished. Now, these are subtasks in the larger production effort for 1632. So notice the create replica is assigned to the background automation user. We have a background process that's automatically creating these jobs when they're ready and actually executing some entirely, like these data replica jobs. So this replica job was created and executed automatically by the background process. After that replica was created, the data maintenance was done. So now data maintenance is done. The background process creates that next job in the flow line, which is for quality control. This one's been assigned to me, so I can just click My Open Jobs and easily find my work. So open that quality control job now. I've run some of the setup steps already, including one that allows me to optionally copy my working files from the network share to my local machine if I want to work locally. The workflow also created a data reviewer session for me here to track my QC calls for the job. So now I can run the open map step and begin my QC. So the workflow opens my organization's template data capture QC map. It's automatically been sourced for me though to the local data that was copied by the workflow to my machine. And it's also zoomed me to the area of interest. So you can see that crosshatched here in red. I'm going to go ahead and turn that off. And at this point, we're ready for our hybrid data capture QC session. So I'll zoom to an area for QC. And if I zoom in a bit here, you can see where the features match each other, but they don't really match the imagery. So I really need to align the forest, the road, and the cropland with the imagery. And in Pro, it's really easy to do that. You can just go to Edit, select all three features. Now find the Reshape tool. Just digitize the correct geometry. And then, all in one go, all three features are modified. So next I'll zoom to an area where we've got some missing features. We really need to do some data capture here, so I'll click the Create tab, and I automatically see a whole list of feature templates that come with defense mapping for the MGCP and TDS schemas. Now these are all templates with predefined attribution, which means I can just click and type, say, trees, to create a feature within the trees A feature class. Now if I think it's deciduous, I can just digitize the feature, and you'll see when I check out the attributes, the feature's been created with the foliage type of deciduous. Now this is a big time saver, especially for features like buildings and roads that have lots of required attribution. So as you can see though, I still need to create my lake here. So I'll search for lake and find my perennial lake feature template. But I'm going to use the production difference polygon tool to create this feature instead. This tool is licensed with production mapping, but it's integrated right into the Pro framework here. So what I can do with this tool is just capture the polygon really sloppily. And the tool is going to automatically fill the gaps between the layers with that new lake feature. This is a real efficiency tool for data capture. There's also another one that comes with production mapping that can quickly help me create buildings to spec. So just find the buildings template and the create structures tool. Now this one allows me to set a tolerance. So it means the tool will create a point if the feature is less than 625 square meters and a polygon automatically if it's more. So I can just zoom in, click 3 points to digitize the building, and you'll see since it's a larger building, it's a polygon. And conversely, if I zoom over here and digitize a small one, it'll be a point. So to summarize, the data capture tools in production mapping, along with the predefined attribution in those feature templates, make it really easy to create data efficiently to spec. Combine that with the workflow automation that makes sure I have the right data checked out, the right map automatically, and it all leads to just more efficient capture of higher quality, best scale data. Now I'll pass it back to Amber, who will discuss some of the potential uses for this best scale data we've captured.
Thanks, GC. Now that we've seen how to capture data, let's discuss how that data, along with generalization rules and models, can be used to produce smaller scales of data. This is done by using automated generalization. With automated generalization, an organization only needs to maintain a single database at the best scale. Automated models and scripts are then used to create data products at other output scales. When designed correctly, these automated processes can maintain the quality and topological relationships of the source while simplifying the data so it's appropriate to the output scale. Production mapping provides a set of generalization models that can be run against any input data schema to produce almost any output scale. We did this by creating a series of theme-based generalization models that understand the characteristics and topological relationships of different types of data, such as transportation and hydro. The generalization rule spreadsheet is used to identify which features in your schema should be generalized with each theme. It also identifies tolerances such as the minimum size of features. The spreadsheet allows the models to adapt to different data schemas and scales. For example, the same set of generalization models can be used to generalize data in the CTM schema from 10K to 50K, or MGCP data from 50K to 250K. All that's required is a different spreadsheet. We provide the generalization rule spreadsheets for CTM as part of production mapping and for MGCP and TDS as part of defense mapping. But a template is also provided so you can build the rules for your own schema. At this point, let's jump over to a demonstration in Pro. This is 50K Vescale data over Haiti. We'd like to be able to use this data to produce a map at 250K. But as you can see, we've zoomed out to 250K and there's just way too much information for us to be able to use it at that scale. So that's where generalization comes in. Production mapping provides a set of generalization models out of the box that can be used with a generalization rules spreadsheet to generalize data. Let's take a look at the results of generalizing this data to 250K using the out-of-the-box models and spreadsheets. As you can see, running the models significantly improves the appearance of the data at our desired output scale. Let's zoom in and take a look at some of the themes of data that we run the generalization against. The first theme of data that we generalize using the out-of-the-box models is structures. So structures deals with buildings and built-up areas. As you can see in the source data, we have a lot of building points and polygons. Too many, in fact, to display at 250K. So rather than displaying all of the building points, we identify those locations where there's dense clusters of buildings and we create built-up areas instead. With transportation, our next theme, this theme primarily deals with our roads. Our road models take into account the classifications of roads as well as the road network and thins out the roads in a way that maintains the overall traversable network while removing features of lesser importance. After we run transportation, the next theme is skin of the earth, and skin of the earth represents land cover features, right? Things like hydro and vegetation and agriculture. We call it a skin of the earth because they should cover our area and there shouldn't be any overlaps or gaps. That means as we generalize these types of features, if we're removing one type of feature, we don't want to introduce any sorts of gaps. So as you can see in our source data, there's a river polygon that runs through this particular area. However, that polygon is narrow enough that it's not really easy to see at our desired output scale. So rather than displaying it as a polygon, we want to collapse it down to a center line. But if we simply removed the polygon, we'd end up with a gap between these two types of vegetation features. Our SOE models take into account all of the types of features and can do things like extend the vegetation into the center line and fill in the area that was removed when we removed the river polygon. The next theme of data is hydro, and hydro really deals with the hydro lines. We've collapsed the polygons to center lines in skin of the earth, and now we want to thin out the hydro network as part of hydro. So you can see that we've kept the main path through as well as a few of the tributaries while removing a lot of the excess detail. The final theme is called general, and that's where we put pretty much everything else that doesn't necessarily have those sorts of topological relationships. So these record danger points, we just want to thin them out. We don't want too many of them in any particular area. Things like sports ground, we might remove all of them because they're not important at this scale. Things like cemeteries, maybe we remove the ones that are smaller than a certain size. And so all of that can happen in the general models. Now, after we run all of our themes, the last thing that we do is we run simplification and smoothing. And we do that on all of the themes of data together. So what that allows us to do is make sure that as we simplify this boundary between our hydro and our vegetation, that coincidence is maintained. And it makes sure that if there's a road very close to the edge of our hydro, that it doesn't end up inside of it after we do our simplification and smoothing. Now that's a quick tour of some of the generalization results. We achieved these results by running a tool called Run Generalization. This geoprocessing tool chains together all of the geoprocessing models and leverages our generalization rule spreadsheet to produce our output. Since the generalization rules are so important, let's look at the rule file we use to create these results. The generalization rule spreadsheet is divided into a number of tabs that serve different purposes. The rules define the feature classes that are going to be generalized and how they're going to be generalized. The tolerances define the sizes of features. The fields define any fields that are used during generalization. So things like if I'm going to aggregate, I want to aggregate based on a set of fields. The spreadsheet also allows us to control how the generalization executes. You can turn on and off different models from running, as well as defining the locations of certain files that are going to be used while you're generalizing. So if we want to modify the results of generalization, we control all of that using the spreadsheets. We don't have to modify any of the models. So as we were going through generalization, maybe we decide that we want to keep more information than what was in the current result. One of the things that we might want to change is how the buildings are generalized. So if you remember, all of the buildings outside of built-up areas were removed, and that's defined right here in the spreadsheet. You can see that the structure remove says that we're removing all of them. If we want to change that, maybe we just remove the ones inside of built-up areas. And then we can thin the remaining buildings based on a distance. The Tolerance tab controls what the distance is that the buildings are going to be thinned by. So if we flip over to the Tolerances tab, we can find that tolerance by searching for it. Let's search for building thin. And we can find the building thin distance. Currently, that's set to 250 meters. I think that's an appropriate value, so let's not adjust that. But maybe there's some other values that we want to adjust. Another area that we looked at was the river polygons that collapse to center lines. That's being done in our SOE collapse model. So we can come in here and choose just the collapse model and see all of the tolerances that relate. The minimum width linear polygons is set to 125 meters. We can reduce this value, let's say to 85. And now that we've adjusted the values in the spreadsheet, we can come back to Pro and execute the Run Generalization tool again against the data to get a different result. I've already done that, so let's take a look. So we can see already that there's a significant difference to the output result. We can see that in the original data, there's a lot of buildings outside the built-up area. In the original 250K, all of those buildings are removed. And in our new output, there's still a handful of buildings, but they've been thinned. We can also see that this narrow river polygon was collapsed to a center line, but in our new output, we can see that it remains as a polygon. We've discussed how we can use the Run Generalization tool with our spreadsheet to produce these output results. Once we're ready to run our generalization in production, the better way to do that is to use workflows. The same workflow system that GC demonstrated also contains generalization workflows. These workflows will manage all of the generalization files and then execute the Run Generalization model. If you're storing the output of generalization in an SDE database, the replace data workflow can extract any existing data, replace it with the newly generalized data, and then run edge matching to dissolve the data and create a seamless output database. And all of that can be run automatically using the workflows. So in this demonstration, we showed you some of the generalization results and how you can adjust them using the spreadsheet and how you can automate them using the Run Generalization tool and the workflows. Up to this point, our presentation has focused on data. Now let's explore how we can use this data along with map templates and cartographic role files to create cartographic products. Here's Johnny to tell us about cartography.
Thanks, Amber. It's Johnny here. GC has shown us collection and all things best scale data, and Amber has shown us how to take that 50K best scale data and generalize it, say, up to 250. Now we're going to take this data into Cartoland. Now, we could use the same process for a 250K product. We're just going to take the 50K best scale data, and we're going to make an MTM50 with it. So we wanted to start with a quick demo of a topographic production workflow inside of desktop ArcGIS Pro. This is a familiar form factor, and it'll give us a look at what's happening on the ground level before we dive into server and enterprise solutions. So let me show you how Generate Product Layout looks and works. So this is our data. Today we're going to be making an MTM50. So we got the MTM50 layout PageX file. We have some MGCP data that's been loaded into this MTM schema. We have a DEM, it's some DTED2, and we have the map index product file. We'll just use that for an AOI. So this is all the data that we're going to need to make our MTM50. But before we hit go on Generate Product Layout, we'll just quickly run some data prep steps. So I'm going to open another tool and show you what those look like. Under Topographic Production Tools, Cartography, Features, there's Generate Topographic Contours. I've already done that, and I've already generated some spot heights as well. And I've already thinned those spot heights out with thin spot heights. All right, so all the data that we just discussed, those contours that I made, the elevation, the MGCP, that's all been populated into this Generate Product Layout GP tool. This is what it looked like when you populate all that in there. But I've already run this, and I want to show you the map that I got as a result. Here it is. All right, so right off the bat, automatically we got 4 grids for each of the 4 map frames for the base map grid, and further down the adjoining sheets guide, the boundaries guide, and the elevation guide. They're all set up to spec and they're ready to go. And all the symbology that we're seeing in the map face is contained within the layers of this table of contents. So if you're new to cartographic production inside ArcGIS Pro, there's no more calculating or configuring. You just source your data and it works. If we look up here, we've got some sheet info that's been updated. We got the country, scale. We've got the sheet name. All 4 of the 1-second notes have been updated. The series number and sheet number. We look further down. The jog note has been updated. We've got spot dots in our elevation guide. We've got a declination diagram. Our contour interval has been updated. Slope guide is appropriate. Meter reference guide. All of this has been run automatically by Generate Product Layout. And one other thing to note, the layout files all have labels that are appropriate for each layer. And so those are accurate to the MTM spec. So Generate Product Layout will automatically convert those labels to annotation so that by the time we open our layout, our annotation is already going to be there and it's ready for us to fine tune. We'll take another deeper look at masking later on. Okay, so just to wrap up, everything we covered, all the map sheet info that was populated, grids that were made, elevation guide features, symbology. These tools are all running under the hood of Generate Product Layout. In most cases, we're not going to think about running them. It's just automatic. We made ourselves a beautiful standardized product that's ready to be refined and finished. And that maybe would start with some of our refinement tools. So if we look at some of those, under cartographic refinement, we can run building offsets to minimize the amount of time that you're going to spend on manual displacement that's going to pull those buildings off of roads and pipelines. Or for example, you've got make masks from rules that automatically generates spec appropriate masks for all of our annotation against every feature in the map. We can then apply those masks from rules here to then automatically apply the masks by color to the map. And that results in a really clean and refined experience. We've got calculate bridge offsets that will pull those bridges away from the road so you get a really clean and refined look for your trans. One other thing I want to show you is that I ran a PDF export on that map. I want to show it to you. Here it is. And the thing I want to highlight is that ArcGIS Pro has native spot color support within Adobe. So if we turn off the spot plates, we're going to see all the output disappear. This is great. Again, there's no production PDF XML file you have to put in. It just works right out of the box. So that is a desktop experience that many of us will be familiar with. We're going to take this ArcGIS Pro desktop experience into a scalable enterprise solution, and we're going to see how workflows can help us manage our data, track users and their progress, and automate some of the processes. From within workflows, we're looking at an even greater level of automation for enterprise situations, and I'm going to show you all about it. All right, so here we are in workflows. This is an AutoCarto workflow job that has already been run, and we're just going to take a look down through the steps and walk you through it a little bit. So the first thing the job is going to do is set its status to working. This happens automatically when it's handled by the background process, and that just lets the system know and potentially letting a tech lead know that the job has begun work. Then it's going to copy the files from the share. It's going to copy whatever it needs, elevation, the MGCP source that's been shared, and it's going to copy only what it needs down so that it can work locally. It's going to extract that MGCP data into the appropriate MTM schema, which again is a prep step that when we did the desktop experience, I had to do manually. That was all done by hand. So this is done automatically inside of workflows, along with all the pre-processing. Again, in desktop, you probably recall I had to create contours. I had to create spot dots. I had to thin those spot dots. And all of those pre-process steps are going to get run automatically inside of workflows. Then it will immediately step on to generate product. This is the generate product layout step that we ran inside of desktop. And on desktop, I had to pull up the GP tool and populate it with all that data. It's not a tremendously difficult step, but it's all done sequentially and automatically within of workflows. Now, here's where the real magic is, running post-process. So in workflows, you can elect optionally to select a number of different post-process steps that can run automatically as part of workflows that on a desktop experience would otherwise be excluded, wouldn't be run as part of Generate Product Layout. And I want to give you a few examples of what that looks like. All right, so take apply building offsets, for example. This is a great tool that cuts down on that manual displacement of roads and pipelines, for example. Now here, I've got another map that I'm working on, and I'm finishing it on desktop. Now, apply building offsets has to be run manually. So I'm going to click Run. Great. So the buildings look awesome. They've been displaced from the roads and from the BUA, but I had to run that by hand in the desktop experience. So I want you to take a look at the workflows. And if you notice, the APRX I've got open from the workflows output has already had apply building offsets run on it automatically because I've elected to run that during the workflows. If we take another look at the PDF, you can see this is the PDF output of that same map. It's really cut down on the amount of manual displacement that these buildings are going to need. Looks great. One other thing to note is that generate masks from rules and apply masks from rules has already been run, as you can see on this black text against these grid lines and against the edges of these BUAs. That's already been run. I've elected to run it as part of workflows, so it was automatic. Again, on desktop, I'd have had to run that manually, but in workflows, you can choose the refinement steps that are appropriate for your project and for your workflow. Okay, so looking back at the workflow, you can see here there's a portion where you elect whether you want an export PDF for that fit for use map or whether you want to go to a zip package with an APRX or PageX for you to refine that last 10 to 15% before it gets sent back to the share. And then at that point, it's going to notify the tech lead. It's going to notify the system. It's going to close this job down. Maybe could potentially open up a QC job on the heels of this. And you can run all sorts of jobs from within workflows. You can do QC. You can do data collection, data refinement, cartography. It's really, really powerful and really, really malleable. So that's a quick overview of workflows. I hope you've enjoyed this quick look. If you've got questions about deployment, if you've got questions about anything, please reach out in the Q&A. And we would love to help you out. But that's it for me. I'm going to hand it back to Amber. Thanks.
Thanks, Johnny. Now that we know how to make data and cartographic products, let's learn about the applications available to engage with stakeholders and external customers outside of Pro. JC demonstrated the Production Manager application. This application allows managers to see the current status of jobs within the Workflow Manager system and to create and reassign work as necessary. Johnny showed us how to use Pro and workflows to create cartographic products. For less technical staff or external customers, the Map Production System, or MPS, can be used to create maps on demand. Johnny's going to show us a quick demonstration of how to use the same geoprocessing capabilities he showed us earlier to create maps on demand using the MPS application.
Thanks again, Amber. So we are jumping right into the demo. This is the first chance we've had to publicly demo Map Production System. We like to call it MPS. MPS is a web app that we've developed that runs right in your browser. So here we are on the landing page, and I've already deployed my data. Again, if you've got questions about deployment, what's running under the hood, pop them in the Q&A in the live chat. We'd love to engage with you. So it says choose a map type on the left to get started. And notice if you've deployed a whole bunch of map types, you can sort them alphabetically, or you can even type in the one that you're looking for. We're going to make an MTM50. It's really easy to use. You select your map version for the data type you've got, TRD46 for me. And under export format, you can choose to go right to PDF for that fit for use map that's hot off the press, or you can get an APRX or PageX zip package that you can open up and refine further. But let's select PDF. So if this is a quick custom job, Maybe you want to look in the map service layers and turn off any layers you don't need for that custom map. And under ancillary layers, you can host boundaries as a service or geonames for some labels, or maybe DevOff for your vertical obstructions. And then you can add those layers right here, right at your fingertips, rather than chasing them around your service or adding them later. Once we've selected the options we want, we can look in the maps, and up here in the base map, we've got lots of options to choose from. I like newspaper map. It's nice and clean. We can select multiple maps with our pointer tool and just double click when we're finished. We can clear the selection with this eraser. We can use the plain old square selection, rectangle selector. And then once we've selected the maps that we want, we move over here and we hit the plus to add them to the export queue. We haven't kicked them off for export yet. We're just kind of staging them here. We can clear our queue if we want with this button here. Now, once you've got maps in the export queue, if you select any one of them, they'll highlight in the map. So if you realize that maybe one of these maps needs a little bit more polishing and you want to go back and export it as an APRX instead, you can click around, make sure you have the right one. Let's trash it. Well, let's add it back in as an APRX. Now you can sort the maps in the export queue alphabetically again, or you can drag them around individually if you want. And I'm going to take that APRX all the way to the top so that it exports first. All right, now if I hit export, they're all going to file out the door. And they're going to appear up in the export tab. And those maps have been sent off to export. We've got our blue bars that are going to begin to fill up, and we can sort our exports alphabetically. We can change the options and search by their start date, by their end date. We can look at just the maps that are completed with their exports or ones that failed. We can sort by their status. Now, if we click on any of the in progress exports, once again in the map, it's going to highlight, but then on the right, we're going to have export details that's going to show informative messages. So just like in desktop, if you want to see the messages, the warnings, any errors, you can view those here and make sure things are going off the way that they should. And finally, when the map is finished exporting, you just get a little download button. You can just download it right there. And this is one that exported to PDF. And there you have it. So if this map is going directly to the plotter, we've got a PDF that for that straight to press option, and you've got PageX and APRX options that have already run generate product, and they're ready to be taken over the finish line for a really polished cartographic product. So we've talked about collecting best scale data and getting it generalized for use all within workflows. And then when you're ready to develop cartographic products, you can choose to automate from within workflows themselves, or you can deploy your data to a more push-button solution like MPS for quick fire service or a more customer-facing solution. And we think MPS is in an absolutely elite tier of cartographic automation. And I hope you've enjoyed this quick tour. And with that, I'm going to hand things back to Amber. Thanks very much.
Thanks again, Johnny. As we reach the end of our session, I'd like to summarize what we covered by saying that topographic agencies invest a lot of time and effort into creating their best scale data. In this presentation, we showed ways to leverage workflows to increase efficiency when capturing best scale data. We showed how geoprocessing models and scripts can be used to automate generalization and create cartographic products. We also showed how you can share your data and maps through applications like MPS. On behalf of Johnny, GC, and myself, I'd like to thank all of you for attending our session today. You can provide feedback to us about the session by using the session survey link below. As a reminder, you can contact any of the presenters or additional experts during the user conference. You can also reach out to us after UC by using the production mapping at esri.com email alias. At this point, we have concluded our content, and we'd now like to take the opportunity to answer any questions you have during our live Q&A. Thanks again for joining our session on automating topographic data and map production.